I've type defined it here as long. It is better to use long because when we are dealing with such numbers, if we end up exceeding the max size of an integer, it will throw us errors, and that is, we might not be able to find out later or during a contest. So long is a safe bet since we don't have much space restrictions. So we go from I equal to 1. We can do it 2 here also, but as I said, for completion, we go from 1 less than equal to n plus plus. So this is going to check all our prime numbers once we add this check, which is prime I equal to true. I can also remove this equal to true because is prime I gives you a Boolean value which will be true or false. And if it is a prime number, so this loop is going through all our prime numbers from 1 to n, and in this inside loop, we are modifying the values of all the multiples of that prime number. J plus. If you do j plus equal to I, it's checking all the multiples of the prime number I. And we are changing it to false because multiples are of course composite. This is basically the part that is sieving our vector and making all primes true and all which are not primes false. And here we can run another loop to simply print out everything that's prime and everything that's not prime. We can just print the primes. If you want to print the composites, we can do that too. Equal to is equal to true. If you want to do the composites, then we can put false there. So I guess that's good enough. I'll run it. Here, if let's start with a small number. Let's say I start with 10. It gives you 2, 3, 5, and 7. So that's the primes up till 10. Let's go a bit higher. Let's say 25. 2, 3, 5, 7, 11, 13, 17, 23. Okay, so that's working. Let's say 100, 1000. And this should be all our prime numbers from 1 to 1000. And you saw how quickly it printed them, right? We don't need to go through much trouble when we are using a sieve. So now I'll let you all, absorb this for a while. Has everyone understood what is going on here? Y'all can reply in chat or on the Slido link that has been sent. And if y'all have any doubts, you can raise hand. Okay, I see no hands. I guess there's a chat. Okay, so I believe you all have understood. It's a pretty simple algorithm. You all can go through the slides after the session and type it out yourself. So here we have a basic program. Now, how to make this even faster? So here we are going from 1 to n. But for prime numbers, do we really need to go up to n? We can go up to root of n also, right? So we can make a certain changes and like this. If we set this also as our check in the if statement, if I into I is less than equal to n. So we are going only up to root n. We don't need to go up to n if we are using, if we just need prime numbers, because anything greater than root n won't divide n. So that's called sieving till root. And you can also sieve by odd numbers only. So here you can do, you can manually set is prime of 2 equal to true, which we have done here. And here we can iterate from 1 and do I plus equal to 2. Because any even number apart from 2 is not going to be a prime number. So we can sieve odd numbers and we can sieve till root. This won't make much difference in the time complexity, but sieving till root will reduce the number of operations, and so will sieving by odd numbers. So here if I add another check, that is n into I less than equal to n. You won't be able to see it, I guess, but it definitely makes the program a bit faster. Yeah. So these are some modifications that you can make to the basic algorithm to make it faster. So now we'll move on to ETF. The ETF is Euler's totient function. This is also the phi function. And what is this function representing? So if we have any number n, say 8, then phi of 8 will be the number of coprimes of 8. So 1 is a coprime of 8, 3 is a coprime of 8, 5 is a coprime of 8, and 7. So for 8, the number of coprimes will be 4. So you all might have learned it, of course, in middle school that two numbers are coprime if their greatest common divisor is 1. So we have n and coprime. So these are just up to 7. And y'all can, write down. I'll give you all 2 minutes. Just write down 1 to 15 and write down the number of coprimes that they have. So write down the totient values from 1 to 15 and try to observe a pattern. Once you all do, I'll move on to the next slide. And until then, if you all have any doubts, please let me know. I'll give you all another minute. Just write them down 1 to 15, 1 to 20, and try to find the totient value by yourself. Totient value is the number of coprimes. Soham Pansal has raised hand, I believe. Okay, no. Yeah, so you all might have observed that the totient value for our prime numbers is 1 less than the number itself. So this is pretty simple because if your number is prime, then it is not divisible by any number other than 1 and itself. So all coprimes will be 1. If we take 7, 1, 2, 3, 4, 5, 6, 7, all of them will be coprimes. If we take 11, then 1 to 10, everything will be a coprime because nothing divides 11 up other than 1. And if 1 and 11, even though 1 divides 11, it is a coprime because it is the GCD itself. So for any prime number, the totient value is that prime number minus 1. Now, this might be a tricky observation, but this is another property of the totient function. If we have any arbitrary k and we have p raised to k, the number whose totient we have to find. So let's say we take 3 and we'll also take k as 3. So p is 3, k is 3. Then our totient value we have to find is of 3 raised to 3, that's 27. So the number of coprimes of 27. So let's go through. We'll have 1, then we'll have 1, we'll have 2, we'll have 4, we'll have 6, we'll have all the odd number, all the even numbers, because none of them are, you know, all the even numbers except multiples of 3. So if we check that, we'll get p raised to k minus p raised to k minus 1. So 27 minus uh, 27 minus 9. So we'll get 18 coprimes for 27. And similarly, if we have p equal to 2 and k equal to 3, so we have to find the number of coprimes of 8. So number of coprimes of 8 will be 1, then 3, then 5, then 7. That's 4. So we'll have 2 raised to 3 minus 2 raised to 2. So 8 minus 4, that's 4. So that's another property of the totient. And if a and b are relatively prime, then there will be no common prime factors of a and b. So like that, we can find that the totient of a into b is the totient of a into the totient of b. So now using this property, we can make a simplification of the totient function and how to find it. So using this property, if we have a number n whose totient we have to find, and p1 up to pk are all the prime factors of n, and a1, a2, ak are the powers of these prime factors by which it's dividing n. So the totient of n will be the totient of all of these numbers, which goes by the third property here. This is the first equation that we've written. The second equation that we've written follows from the second property here. And if we bring out the p1 raised to a1 and p2 raised to a2, then we get this p1 raised to a1, p2 raised to a2 is nothing but n. So this is our final value of the totient function. So now let me ask you, do you observe any similarity to the sieve of primes here? So in sieve, when we go here, yeah. So we are good. Uh, we have number of operations as n into 1 by 2 plus 1 by 3 plus 1 by 5 plus 1 by 7, but these are our prime numbers. And this is our required number up to which we have to find the primes. In totient, this is our number. And this is 1 minus 1 by the first prime, 1 minus 1 by the second prime, which are all the prime factors of n. So we can use an idea similar to the sieve of Eratosthenes to find the totient array or the totient vector. So what will we do? We find all the prime numbers, and for each one, we update the temporary result. So we'll make a vector called phi itself or the totient, and we'll store a certain value initially. Let's store the number itself. And here, so we store the number itself initially. And then as we move on, every time we find a new prime number, we multiply the totient value of all its multiples by 1 minus 1 by I. So here we'll go to this prime number, say P1. We'll go to all its multiples and then multiply that by 1 minus 1 by P1. So any multiple of P1, say n, will be multiplied by 1 minus 1 by P1 when we encounter P1. Then we move on. When we encounter P2, we'll multiply this number by 1 minus 1 by P2. So that's how we'll go through the entire vector. And in the end, we'll have all the values, which are the totient values. All right. So this is the implementation of it. Go through this once. I know it might be a bit fast, so just try to associate the manual calculation of totient that you did earlier with the algorithm that we are using here. So here we are initially setting all the totient values to the number itself. And again, here we use n plus 1 and a vector of integers because we want to store the number itself. And n plus 1 because you want to go from 1 to the number n itself. We want to, the last index should be n. And here we are, like we did in Sieve, this is our first for loop, then a check statement, then the other for loop. So when we go from, say, I equal to 2, so 2 is a prime number and we haven't changed anything before this. So the totient of 2 will be equal to 2. So we'll go inside this if statement. And now for loop will run from j equal to I. So 2 up till n, and it will increment by 2 n. So initially, the totient value of 2 will be reduced by totient minus totient by I. So j equal to I initially, so that will be reduced by 1. For 2, the totient value will become 1. Then when we increase by 2 again, j will become 4 and I will be 2. So for 4, initially we have stored the totient value as 4 itself, but now we are doing 4 minus 4 by 2. So now it is 2. When we go to 6, the j is 6, I is 2. So initially the totient value is 6, but then we do 6 minus 6 by 2. So it becomes 3. And similarly, we keep on moving until we cover all the primes and all the totient values, and we get the final vector, which contains the totient values from 1 to n. I'll show you all this in VS Code also. So yeah, we have our number n up to which we want to find the totient. Then we'll make a vector using integers, if phi, and we make it of size n plus 1. Initially, we set it all the values up to n equal to I itself, because that will help us identify if it is a prime or not. And it will, since we are multiplying it by 1 minus 1 by I, 1 by the prime factor, we need to multiply the n number for the totient. So this part. So this n, initially the phi n will be n, then we are going to the prime numbers. That's why initially we set phi of I equal to I. So phi of I equal to I. Now we run the loops. So I equal to 2. Here you can use long also, but I'm just using integer here. So if the totient of I equal to I itself, which means it has not been changed previously, so it is a prime number. So now we go from j equal to I. So in the first iteration of this inner for loop, it will change the totient value of the prime number and reduce it by 1, because totient of each prime number is that number minus 1. J plus equal to I. That's basically going through all multiples. Phi of I equal to phi of I minus phi of I. No, sorry, phi of j should be here, because we want to change the values of the multiples, not including that number itself. But if you do phi of I, it won't change the values of the multiples by I. So this is the same as multiplying phi of j by 1 minus 1 by I. It just, we write it here. And now we simply print it out. I equal to 1, I less than equal to n, I plus plus. I of I, the end the line. So this gives us our totient ETF program. So I press run here. Let's enter say 10. These are the totient values up to 10. So totient of 1 is 1, because 1 is co-prime with 1, nothing else. Of 2, it's 1. It would be easier if I do it like this, I guess. You'll be able to see better. Quotient of 1 is 1, 2 is 1, 3 is 2, because 1 and 2 both are co-prime with 3. 4 it's 2, again 1 and 3 are co-prime. Then 5, 4, 7, 6, 9, 6, then 10, 4. Similarly, we can put a large number also. I'll put 100. And these are the total values that we get. The algorithm is pretty efficient and quick. So I'll give you all a while to note this and absorb this so that there's no doubt. You all can refer to the slides after the session also to refer later. This is the ETF and this is the Sieve. Yeah, that's about it for Sieve and ETF. Now Chehel and Sean, they will tell you all about the roadmap and how to progress in CP further, how to improve yourself, and what after this camp. This camp is not everything that you need to cover, right? Uh, you so yeah, I think Haricharan is here. So yeah, Haricharan, over to you now.
Yeah, hello. Can you people hear me?
Yes, we
Okay,
can hear
please,
you.
please.
Yeah, you're visible.
Okay, okay, right. Give me a minute. You can stop sharing, I guess. I'll start sharing. Okay. Okay. Yeah. Hopefully my screen is visible.
Yes, it's visible.
Okay, please, please. Right. So hopefully all of you had a good session in CCC. So I'm Haricharan and I'm one of the core team members of Programming Club. So this will be like a small session on what you can do after CCC. So in CCC, we have introduced you to all the basics like taking inputs and all those things, and we have like trained you enough to a certain level. But there is a lot more to be learned in CP, and we are going to give you a small introduction of what more you can learn in CP. So hopefully that's fine. So like how do you continue CP, right? That's the big question. So we have covered all of these things so far. So in the very first session, we saw how to take input and output. After that, we saw about like if and else statements, and we saw about for loops also. After that, we talked a bit about arrays, vectors, and strings and stuff like that. And then we actually moved on to sorting, and then GCD recursion, prefix sums, frequency array, and then gradient and brute force, and then like binary search and two pointers. And then we moved on to STL data structures like map, set, and like queue, deck, etc. And then finally we talked about like Sieve, ETF, and modular arithmetic in today's session. So all of these are kind of basic topics. They're enough to get you started, but of course they are like if you want to get a really high rating, you have to learn a lot more topics. So we have prepared for you some kind of like basic roadmap on how you can continue a CP journey. So your CP journey is like so like we are CCC right now. Now after that, I think in binary search itself, you can like do a lot more things like in binary search itself. In fact, I'll quickly demonstrate that to you. Uh, so like if you go to Codeforces website, you can see something called Codeforces Edu here. So Codeforces Edu, essentially it has like a bit more. One second, I will sign in. Give me a minute. Okay. Okay. So in Codeforce Edu, you can see like there are various topics here, and you can see binary search here. So in our binary search session, we would have covered like the first two topics among these. But using binary search itself, you can do much more, and you can learn about like advanced binary search and how you can actually use it. And even in prefix sums, you can do stuff like something called a difference array and stuff like that. Like we'll provide links to all of these things. Don't worry for now. But yeah, that's one more thing. And then you can learn like more mathematical stuff like learning like more detailed concepts about the Euler totient function, Sieve, and factorization, like some kind of number theory kind of thing, how we can like play with numbers and like come up with CF solutions. So like you can do very interesting stuff with like GCD and all. That will be one more thing. Now like first three you should be able to complete in like the next month or so, but after that how do you proceed? So after that, the main topics we enter into that. So that will be actually dynamic programming and graphs. So what is DP or dynamic programming is shortly called DP. So in dynamic programming, essentially it's to uh, like like one analogy would be if you're trying to compute the same thing many times, we instead do it just once and we store the value. So I'll give an example very shortly. But the fundamental idea is that instead of doing the same thing again and again, which will take a lot of time, we instead do it only once, which will like essentially save you a lot of time and will make your code run faster. That's one intuition of how DP works. And then we have graphs. So graphs are like it's not your graph which you studied in school, like not a graph paper if it wasn't clear. This is like essentially you have a bunch of nodes. Nodes are something like a bunch of points, and they're not connected in some way. And the question is what you can do with that. So that's called a graph. So and then you can move on to more advanced data structures. So we would have learned about some basic data structures like maps, sets, queue, stack, deck, etc. But there are a lot more data structures like segmentation tree, DSU. DSU is disjoint sets union, and then we have trie, etc. We have many more data structures, and you can try learning that after a while. And then of course in CP there is no like upper limit. There are a lot more things you can learn, and as and when you reach that level, you'll have enough resources to proceed with the journey. But for now, this is like a rough roadmap of what you can learn. So let's talk a little bit about what is dynamic programming. So like you hopefully know the Fibonacci sequence from school itself. It is something like the nth term is the sum of n minus 1th and n minus 2th terms. The 0th Fibonacci number is defined to be 1. The first Fibonacci number is also defined to be 1. So the first few terms are like we have 1 and 1. After that, 1 plus 1 is 2. After that, 1 plus 2 is 3. 2 plus 3 is 5. 3 plus 5 is 8. 8 plus 5 is 13, and so on. And in this, how do you get the nth term? Okay. So you can think about this for a minute or two. I'll wait till then. I'll have a look at the chat also. Like if you have any ideas, you can put in the chat box. Okay. So we learned about recursion, right? So like one thing we might be able to do is actually to do something called recursion. So like we can come up with a recursive solution where like we have defined a Fibonacci function that is like essentially you say that just Fibonacci of n is like Fibonacci of n minus 1 plus Fibonacci of n minus 2. But actually, can you see an issue in that? The issue is as follows. So let's say I want to calculate a fib of 5. Okay. Uh, yeah. So if I want to calculate a fib of 5, let's see what we can do. I'll just add a text box here and I'll type it here itself. So if you want to calculate a fib of 5, what all like how many function calls do we need to do essentially, right? So we have to do fib of 5. I'll zoom this up a bit. Okay. So we need to do fib of 5 itself. After that, we have to do like fib of 4, right? Like first thing we have to do is we have to call fib of 5. Now fib of 5 will recursively call fib of 4 and it will call fib of 3. Okay. Now the issue is fib of 4 will again call fib of 3 and it will call fib of 2. Like, do you see how this is going? Because like we called fib of 5. Fib of 5 recursively called fib of 4 and fib of 3. But fib of 4 again recursively calls fib of 3 and fib of 2. Likewise, fib of 3 will again call fib of 2 also. So this is a bit problematic because we are essentially doing a lot of unnecessary function calls. So this recursive solution, even though it's good enough, we are calling fib of 3 multiple times, and that's unnecessary. So instead, what is the correct solution? The correct solution is to actually throw it in an array. So we'll have a look at how we can do that. So I have an array called Fibonacci of n plus 2. In that, I'm just like putting a simple for loop over here. In that for loop, I'm just taking the ith Fibonacci number to be the sum of I minus 1 and I minus 2th Fibonacci number. And that is like the basic idea of how Fibonacci numbers might work. Now, DP is like a very vast topic, and there are many other things you can do. One example is something called a knapsack problem. So a knapsack problem is like essentially there is some thief kind of. A thief tries to steal from a house. That house has like various weights and various values. Like that house has many items. Each of the items have various weights and various values. Like its weight could be like 1 kilogram and its value could be like let's say 10 rupees. Like this, you have one more item which is like 7 kilograms and cost is like 15 rupees. And what is the optimal combination? Like which of these items do you take and which do you not take? So that's something called a knapsack problem, which you can solve using DP. So like that's some simple examples of this. So I've provided some like common resources here. Like you can have a look at more things also. Like I mean, there are more links which will provide to you, so no need to worry about that. So that's the basics of DP. Now let's move on to graphs. So basically, what is graph? Graph is essentially you have a bunch of nodes. A node you can think of as a point. So it's really just some point, and between various nodes we have connections. These connections are called edges. So we have a bunch of nodes, and between all the nodes we have some connection. Now the question is, what is like the shortest path from node 1 to node 5? Like so, the question is like you can think of this as nodes being some cities. So one could be something like Chennai, two could be something like Mumbai, three could be like Delhi, etc., etc. And everything in between are like the distances between them in kilometers. So like between 1 and 2, there is between Chennai and Mumbai, there are like 8 kilometers, etc., etc. Now the question is, what is the shortest path that goes from like city 1, that is let's say Chennai, and city 5, let's say it is something like Hyderabad, let's say. So turns out there are very good algorithms which can do this, and this is actually very useful because even stuff like Google Maps and all those things, they use like similar algorithms for this. So hopefully that's clear. So for graphs also, we have given a couple of websites. You can have a look at these things. Graphs, there are again many algorithms. When we're talking about graphs, one more thing is something called a tree. A tree is essentially a subset of a graph. So trees are specific kinds of graphs, and they have like their own separate algorithm. So we can learn about them also. So that's one more thing to learn. But of course, what is the most important resource in my opinion? Actually, in all of our opinion, it will be practice and giving regular contests. So like keep on practicing like a bunch of problems till you can hit the necessary rating you want, and like keep giving regular contests. So Code Forces contests like twice a week, or I mean like approximately twice a week, and CodeChef also conducts contests roughly once or twice a week. So I think it's essential that we give all the contests without fail. So only if we give all the contests without fail, we might be able to increase our rating. So like the most important thing is to keep giving contests. So hopefully that's clear. So like that's essentially some like basic outline of what we want to do here. Like essentially a basic outline of how you can get started with CP. So I've provided you like I've made a couple of links also. We'll be sharing this doc anyways, but I'll quickly tell some of them. So we have like CP resources here. Like we've given you like guide to CF and like guide to USA CO. USA CO is like one popular website kind of. So like USA CO is some website which contains like many useful topics. So you can have a look at all of like these topics. These are all like essentially common like topics kind of. And there are like more detailed explanations on that. And then more on C++. So C++ is a very like advanced language with a ton of features. So like C++ has like so many interesting features that we might not usually use. But the thing is, there are like various things you can do to make your code more optimized. You can do stuff like essentially something called pre-processed directives and stuff like that, which will make your code much faster. So that is these things. Some CP algorithms is like yet another popular website. That website contains many common like uh, common algorithms. It has like from the basic to very advanced algorithms. So you can have a look at all of that also. And then where do you actually practice CP, right? So you can practice CP in like Code Forces. I mean, Code Force you would have known because we actually recommend that you use Code Forces. But apart from that, there is also CodeChef. CodeChef is like Indian, and it's like the learning curve is a bit easier. So in CodeChef, you can get started a bit easier. CSCS is like an extensive problem set. It's probably my favorite problem set. So I'll quickly show that to you. So like you have a bunch of problems like this. Like you have like many problems, and like you can try solving all of these. So like with everything that you learned in the session, you should be able to solve like about 30 or 40 of these, and you can keep learning more concepts to solve all the other problems also. So yeah, that's one more thing. And then AdCoder also, I think it's a Japanese website or something that contains that conducts regular contests. So AdCoder also contains like weekly contests. You can try giving that also. Lead code is something more of an interview preparation. So you'll have various coding interviews, right? So if you're going for internship or placement, you might have various coding interviews. Lead code contains problems in like DSA based on that. So Lead code is also a very good website. Geeks for Geeks is again like a very good website which contains explanations of all common things. So if you want to learn about some topic, like any random topic, let's say I put something like knapsack DP. So I can just search knapsack DP, and Geeks for Geeks shows up here. So I can just look at the Geeks for Geeks page, and I'll be able to understand how the code works. So like that's why we are trying to learn knapsack DP. But yeah, so that's one more thing. And of course, Coding Ninjas is also one more like popular website. Now, one more thing. Again, I showed you this also. Code Forces Edu is like a subset of Code Forces basically. In this, you can enroll yourself in the ITMO course, and it has like many topics. You can see all of those here. So you can probably get started with like binary search, and after binary search, you can maybe go to like suffix array or 2 pointers, and then you can go to DSU, and then finally you can go to segmentation tree and like the various parts in that. So like these are some of the common topics you have to learn. So I've mentioned all of like those things here. But yeah, like we are making some changes here. We'll add all of that and we'll send you the final compiled version. But yeah, okay. Hopefully that's clear. So like one more thing, I want to show that like essentially how you can give your contests. So I'll share my code process. Okay. Right. Hopefully my CF is visible, right? So like CF like conducts various like topics basically. Oh, also someone in the chat box has asked me to explain about dynamic programming. I'll like we'll give you links. Like I'm just trying to give you essentially a gist of like what we are trying to explain. Like I'm not trying to teach you like entire DP itself. It's more like a flavor of what DP is about. So hopefully that's clear. So like CF, if you look at this, if you go to the contest page, you can see when all the contests are being held. So for instance, you have contests like fairly regularly. So we have one contest on like July 25. That is like basically tonight. So you can still register for this contest if you haven't registered already. And then we have one on 27. That's day after tomorrow. And then we have like two parts of the same contest on 29th. So like we have contests fairly often, as I'm saying. Like we'll have contests like roughly once in every like 2 or 3 days basically. And it's essential that you give contests regularly. Like it's strongly recommended that you give contests regularly. So hopefully that's clear. Yeah, apart from that, like you can keep practicing also. Like if you look at some of the top coders from IITM, I'll quickly show that also. Uh, like if you look at some of the top graphs from IITM, you can see that they have solved like roughly 3,000 problems, and like they've solved like 2,000-ish problems. So the point I'm trying to make here is the more problems you solve, like the more your rating will go up. And like look how many problems they have solved per day. They have solved like at least 4 or 5 problems per day. So like that much if you practice, definitely you'll be able to get a good rating. So that's all I wanted to say. It's essentially just a flavor of how you get into CP. This is not meant to be a session like in which we actually teach you the concepts. It's more like what you can do and how you can proceed your CP journey. So I think that's it from my side. So like that's essentially just a basic gist of this. Chahil, you have anything to say?
Yeah. So essentially, Haricharan almost covered everything that you can do in the future. But what I would like to do is like even if say you got left out in the camp in some point like previously, then I would really encourage you to probably like go behind, start and try to solve each and every problem set. Because the most important thing in CP, as Haricharan said, is doing practice. So you should try to practice as much as possible, give every contest. And the most important thing, like one more important thing is that realize that rating is just a number. Don't try to get too much value out of just rating. So it's fine to like even lose rating in a contest. It might feel bad, but the most important thing is to learn. Like even if you couldn't solve some problem in the contest, go to its tutorial, understand what its solution was, and learn forward from that. And it's a sort of an iterative process, and progress usually comes over time. But it's about putting the effort, and you might even get to go to ICPC or other contests over a period of time. And yeah, I guess that's it from our side. Thank you for being a part of this camp and sticking till the end. All the best to your journey in the future. That's essentially it from our side. If you need any help in CP in future also, you can feel free to text us. any of the core team members, and we'll try to help you whenever we can.
Okay, someone is raising their hand. I'll allow mic for them in case you want to ask anything. Like if you have anything to ask, like orally, I'll give you mic access so you can unmute and ask. Yeah, Shyam, you have anything?
The attendance link was sir.
Sorry.
Attendance link.
Oh, okay. Today's attendance link.
Yeah, yes, sir.
Okay. Give us a minute. Today there won't be any attendance. So like no attendance for today.
Okay, sir.
Okay.
So what about certificate?
Yeah, certificate you'll be getting from the CFI team. So like CFI team will be providing you certificates. Like it will come in like you have to ask the CFI people when it comes, but it will come like at the earliest.
Okay, sir. Fine.
If you have any other doubts, you can like raise your hand and ask. I'll provide you mic access. Otherwise, you can leave also. The session is over from us. Okay. Rahul has a doubt. I'll give mic access. I've given you mic access. Rahul, I've given you mic access.
Hello,
Yeah. Yeah, we can hear you.
am I audible?
Yeah, you're audible.
So my question is like whenever we are giving some contest, then after solving some of the question which are given in the tutorial, we are not able to understand. So in that situation, what we can do?
Like you can like try reading the concepts in a particular video. Like if you have some editorial which you're not able to understand, you can like learn the individual concepts. Like let's say you're not able to understand some word. Let's say you have some word like let's say Fourier. Like let's say you have something like FFT or something. Let's say you're not able to understand the word FFT, then you can just search the word FFT in Google, and Google will provide you like explanation of that particular word. Yeah, so like since you are getting that explanation, you can try reading the tutorial again. That's one thing you can do. One more thing you can do is you can look at submissions for that. So if you're not able to understand the editorial itself, you can look at submissions of popular like popular coders. Like you can have a look at maybe one of our submissions, or you can have a look at like world's top grandmasters like Jiang Li or Tourist or something like that, and you'll be able to understand the code in their solutions. Like worst case, if you're not able to understand like that also, then we'll be uploading video tutorials in our YouTube channel. So from our YouTube channel, you should be able to understand the topic.
Okay.
Okay. You can either like raise your hand if you have any doubts, or you can put in chat box. Anything works. If you don't have any doubts, you can leave.
I think we can end the meeting in like 2 minutes if there are no more doubts.
Okay, so Nidhi is asking, like, what if we're not able to solve a particular problem? So, like, I mean, like, what I think would be better is, like, I mean, you can try essentially to like, you can try solving the problem for like 20 to 30 minutes. If you're not able to do that also, then like what you can do is you can have a look at the editorial and try to understand the editorial. So that's okay. Editorial is not given. Editorial will usually be given for code forces contests. So editorial should be there. But if you're not able to do that, you can okay. If you're not able to find get an editorial, then you can have a look at essentially some you can ask it in some CF blog or something. So code forces allows you to essentially post blogs kind of. So you can post a blog about a particular question and ask that question in CF blog, or you can even text it in our CCC group or something, and we'll do our best to help. Okay. Okay, so you're saying editorial is not given before the deadline. Chahil, you have anything to add?
The editorial for which one, like the contest or the previous problem sets? For the problem sets, we'll add all the editorials. Like, sorry for the delay, but yeah. So essentially, we'll be updating all editorials. Like, it's a bit of delayed from our side. Sorry for that, but yeah.
Parth has raised their hand. I've given them mic access. Yeah.
Am I audible?
Yeah, you're audible.
I want to ask, what are the virtual contests? Like, what is a virtual contest? And like, if we have to absolve something, then it is okay with virtual contest or like doing normal way.
Okay, so virtual contest is essentially it will be the exact same experience of having a contest. So you can give a contest at a later time. Let's say the contest was today. You can give the contest tomorrow also, and you'll have a similar experience. Like all the standings, everything will be as it was in that contest. Like you'll have very similar experience, except that your actual rating won't change. So it's essentially like a sample contest in which your rating won't change, but otherwise the experience is the same thing as it was in the original contest. Having a virtual contest and absolving, they have their pros and cons. In virtual contest, the advantage is you will have a particular time limit. So like you should be able to solve within the time limit. Like it will have the same time as the contest, so it's like 2 hours. So you should be able to solve the virtual contest in 2 hours. But the thing is, if like virtual contest, if you have any instead of virtual contest, if you're trying to absolve, the advantage of absolve is you can have a look at the editorial. So you can get some ideas from the editorial itself. So there are pros and cons. You can do anything. Even if you do virtual contest and you are able to solve it, then also it's good. Then that is also good. Nothing wrong with that.
So can we make a mashup of problems and then do a virtual contest on that?
That's a good thing to do. Yeah. Me and Chahil also do it. Yeah. It's a good thing.
Okay, thank you.
Like what you can do is, so find a few problems in your rating range, create a mashup of them, and give that in a time way, like 2 hours or something. So that way you have incremental progress in the problems of your rating range. So that effectively helps you grow better.
Okay. Maulish, you have something to ask? Okay, nothing. Fine. Okay.
Hello.
Yeah.
Hello. So I wanted to ask that how can, like, I'm facing this problem that if I'm solving some problem, either the idea is something that takes me a lot of time to reach, or it is something that I feel that it was very hard to reach. And I'm facing the problem in reducing the time of getting to that idea or being able to reach it quickly, basically. So how can we improve that?
Basically practice only, nothing else. So the more problems you practice, the faster you can get the idea. But some things you can do is if you don't want to code up the entire thing, if it takes a lot of time to come up with the entire idea, you can try to basically have some template or something that will enable you to code up the idea faster. So if it takes a long time for you to get the logic behind the problem, like it's still fine. Like it's just practice only. Keep practicing more, and you will be able to solve it faster. Yeah. Puneet, you have something?
Yeah, so like I've been following all the topics, and after like binary search, I did understand what you guys thought, but I was not able to implement it that well when I'm solving the problems. So like I was not able to solve the very first problem for a long time, and coming up with the solution for the second one was almost impossible. So like, should I learn the concept again, or should I just solve questions?
Like try learning the concepts again. Like I mean, we have like recordings of our sessions also. You can have a look at that, or you can have a look at like Geeks for Geeks page or something which might have a different explanation which you might understand better. Like we have provided all the links, right? So you can have a look at one of those links and see if any of those will help you understand that. That's one more thing you can do. Like apart from that, like the topics themselves get a bit harder. Like towards the end, the topics are like conceptually, they're not as easy as the initial ones. So I think it's natural that it takes more time, and taking more time is fine. So like you might have to spend more time on it. It's fine. You won't be able to spend the same amount of time for the first few problems as the last few problems, and we think it's fine and like natural.
One thing that I'll add is, so for like topics like binary search and 2.2, I'll strongly suggest you to check the code force edu section because it teaches you the implementation as well. And for the other topics as well, just check the slides once and the recording once to see the implementation, and then try to implement it yourself. So like learning the implementation is pretty important because you need to understand how the algorithm works essentially.
Okay.
Any other doubts? No one else has doubts. Okay. No one else has doubts. We'll end the meeting. We'll wait for 2 more minutes. If no one has any doubts, we'll end the meeting. Okay. Rahul has something. Yeah. Rahul, you have anything? You have mic access.
Hello. So the resources which you have provided for the DP, will it be sufficient, or we have to look for others also?
It's sufficient. Yeah. Like all the links we have provided is like more than enough. I mean, there are other resources also. You can just search DP in Google and use all the resources which comes up. But what we have provided themselves should contain like roughly 100 plus problems overall. Like if you combine all the resources, you'll have like 100 problems, and that should be enough for you for a while. So like that is enough to like know the concept.
Okay, thank you, thank you.
Siam, you have something? I've given you mic access. We are not able to hear you. I think you're unmuted, but you're not able to hear you. We are not able to hear you. Do you have something to ask, Siam? Like we're not able to hear you right now. I think it's some technical issue. You can always text us. Like you can text in the group or something maybe. I'm not able to hear. That's fine. I think that should be it. Like if there are no more doubts. So, Saim, I'm not exactly sure what is the issue. I'm not able to hear you.
I think you can ask on the group because they're not audible here. But
Yeah,
I
I got
guess that's it in the meeting then.
Yeah, if no one else has any doubts, we'll end the thing. Okay, I think we can end for now. Jahil will end.
Yeah, and
Okay, please. I'll end off then. If you have any more doubts, you can always ask in the chat. Thanks for attending. Hope you had fun. And hope we meet again. But yeah, bye bye.
thank you. Bye.